You look at our solar system, it seems logical that the planet closest to the sun would be the hottest. But here's a twist: Venus, not Mercury, holds the record for the highest temperatures. This video explores why Venus is hotter than Mercury, even though Mercury sits right next to the sun. We'll break down the science behind planetary heat atmospheres and the greenhouse effect, making it easy to understand why Venus is the real heat champion. Get ready for a journey through space that challenges your expectations and reveals the secrets of planetary temperatures. Mercury is the closest planet to the sun, which means it receives intense sunlight every day. You might expect this to make Mercury the hottest planet in the solar system. However, Mercury's unique characteristics play a big role in its actual temperature. Its proximity to the sun gives it scorching days, but there's more to the story. Let's look deeper into what makes Mercury's environment so extreme and why it doesn't hold the title of the hottest planet. One of the most important factors affecting Mercury's temperature is its almost non-existent atmosphere. Unlike Earth or Venus, Mercury doesn't have a thick layer of gases to trap heat. This means that when the sun shines on Mercury, the surface heats up quickly, but as soon as night falls, that heat escapes just as fast. The lack of atmosphere leads to dramatic temperature swings, from blistering heat during the day to freezing cold at night. During the day, Mercury's surface can reach temperatures of over 400 degrees C, 750 degrees F. This is because the sun's rays hit the planet directly with no atmospheric protection. The surface becomes extremely hot, but without an atmosphere, there's nothing to keep the heat in once the sun sets. This results in a planet that's scorching during the day and icy cold at night. Night falls on Mercury, temperatures drop dramatically. Without an atmosphere to trap heat, the warmth from the day escapes into space. Mercury's nighttime temperatures can plunge to minus 170 degrees C, minus 275 degrees F, making it one of the coldest places in the solar system after sunset. This extreme contrast between day and night is a direct result of its thin atmosphere. Venus is the second planet from the sun, sitting just beyond Mercury. You might think being farther from the sun would make Venus cooler, but that's not the case. Venus has a unique set of features that make it the hottest planet in our solar system. Let's explore what sets Venus apart and why its temperature is so much higher than Mercury's. Like Mercury, Venus has a very thick atmosphere made mostly of carbon dioxide. This dense layer of gas acts like a blanket, trapping heat and preventing it from escaping. The atmosphere is so thick that it creates a powerful greenhouse effect, making Venus's surface incredibly hot. The presence of this atmosphere is the key reason Venus is hotter than Mercury. Greenhouse effect is a process where sunlight enters a planet's atmosphere and heats the surface. On Venus, the thick carbon dioxide atmosphere traps this heat, preventing it from escaping back into space. This creates a cycle where the surface gets hotter and hotter, reaching temperatures around 470 degrees C, 880 degrees F. The greenhouse effect is much stronger on Venus than on Earth, making it the hottest planet. Thanks to its powerful greenhouse effect, Venus's surface temperature is consistently around 470 degrees C, 880 degrees F. This is hot enough to melt lead. Unlike Mercury, Venus doesn't experience huge temperature swings between day and night. The thick atmosphere keeps the heat locked in, making the planet uniformly hot all the time. Venus is covered in thick clouds of sulfuric acid. These clouds add another layer of heat-trapping power, making the planet even hotter. The clouds reflect sunlight and trap heat, acting like a giant pressure cooker. This combination of thick atmosphere and dense clouds makes Venus's surface one of the most inhospitable places in the solar system. Unlike Mercury, Venus's heat doesn't escape at night. The thick atmosphere and clouds keep the surface temperature high all the time. There are no oceans or weather systems to cool the planet down. This means Venus stays hot day and night across the entire planet with almost no variation. Let's compare Mercury and Venus side by side. Mercury is closer to the sun but has no atmosphere, so heat escapes quickly. Venus is slightly farther but has a thick atmosphere that traps heat. This key difference explains why Venus is hotter despite its distance from the sun. Atmospheres play a crucial role in determining a planet's temperature. Without an atmosphere, heat escapes quickly, as seen on Mercury. With a thick atmosphere, heat is trapped, as on Venus. This simple principle helps explain why Venus is the hottest planet, even though it's not the closest to the sun. Earth's atmosphere is just thick enough to keep our planet warm, but not so thick that it traps too much heat. The balance of gases like nitrogen and oxygen, along with a small amount of carbon dioxide, creates a comfortable climate. Unlike Venus, Earth's greenhouse effect is moderate, allowing life to thrive. Venus's greenhouse effect is much more intense than Earth's. The thick carbon dioxide atmosphere traps almost all the heat, leading to extreme surface temperatures. This runaway greenhouse effect is what makes Venus the hottest planet in the solar system. Mercury experiences some of the most dramatic temperature swings in the solar system. During the day, it's extremely hot, but at night, it's freezing cold. This is because there's no atmosphere to hold onto the heat. The planet's surface is constantly changing from one extreme to another. Venus, on the other hand, has a surface temperature that stays nearly the same everywhere all the time. The thick atmosphere and clouds ensure that heat is distributed evenly across the planet. There are no cold nights or cool spots, just relentless heat. Venus's atmosphere is made up of about 96% carbon dioxide with thick clouds of sulfuric acid. This composition is perfect for trapping heat and creating a powerful greenhouse effect. The result is a planet that's much hotter than Mercury despite being farther from the sun. Mercury's atmosphere is so thin that it's almost non-existent. It's made up of trace amounts of gases like oxygen, sodium, and hydrogen, but these are too sparse to trap any heat. This is why Mercury can't hold onto the warmth from the sun, leading to its extreme temperature swings. The surface pressure on Venus is about 90 times greater than Earth's. This intense pressure, combined with high temperatures, makes Venus's surface incredibly hostile. The thick atmosphere not only traps heat but also creates crushing pressure, adding to the planet's extreme conditions. Mercury's surface pressure is almost zero. Without a substantial atmosphere, there's no pressure to speak of. This lack of pressure means that Mercury's surface is exposed directly to space, contributing to its rapid temperature changes. Venus's clouds are made up of sulfuric acid and are extremely thick. These clouds reflect sunlight and trap heat, making the planet even hotter. The cloud layers add to the greenhouse effect, ensuring that Venus's surface stays scorching. Mercury's surface is covered in craters and rocky terrain. Without an atmosphere, there's no weather to erode or change these features. The planet's surface remains exposed to the harsh environment of space with no protection from temperature extremes. Venus's surface is hidden beneath thick clouds, but it's known to have volcanic plains and mountains. The extreme heat and pressure make it impossible for humans or spacecraft to survive for long. The surface is constantly reshaped by volcanic activity, adding to its inhospitable nature. Venus doesn't have weather systems like Earth. The thick atmosphere and clouds keep the planet's temperature stable and high. There are no oceans or winds to cool things down, so the heat stays locked in all the time. Mercury doesn't have weather either, but for a different reason. Its thin atmosphere can't support winds or clouds. The planet's surface is exposed to the vacuum of space with no protection from the sun's rays or the cold of night. The thick atmosphere on Venus ensures that heat is distributed evenly across the planet. There are no cool spots or cold nights, just relentless, uniform heat. This makes Venus's surface one of the most consistent in terms of temperature. On Mercury, heat is not distributed evenly. The side facing the sun gets extremely hot, while the side facing away becomes freezing cold. The lack of atmosphere means there's no way to move heat around, resulting in dramatic differences between day and night. Exploring Venus's surface is a huge challenge. The extreme heat and pressure destroy spacecraft within hours. Only a few missions have managed to send back images before being destroyed. Venus's harsh environment makes it one of the most difficult planets to study up close. Mercury's surface has been explored by spacecraft like Messenger. The lack of atmosphere makes it easier to land, but the extreme temperature swings pose a challenge. Instruments must be able to withstand both intense heat and freezing cold. Venus is believed to have active volcanoes. The volcanic activity adds to the planet's extreme environment, releasing more gases into the atmosphere and maintaining the thick cloud cover. This ongoing activity keeps Venus's surface hot and dynamic. Mercury has evidence of ancient volcanic activity, but it's not active today. The planet's surface is shaped by impacts and craters with little change over time. The lack of atmosphere means volcanic gases escape quickly, leaving no lasting effects. Venus's environment is incredibly hostile. The combination of extreme heat, high pressure, and acidic clouds makes it impossible for life as we know it to survive. Even robotic probes struggle to last more than a few hours on the surface. Mercury is also a hostile place, but for different reasons. The lack of atmosphere exposes the surface to space, and the temperature swings make it impossible for life to survive. The planet's surface is battered by meteoroids and radiation from the sun. The thick atmosphere and clouds on Venus act as a massive heat trap. Sunlight enters, heats the surface, and the heat is locked in by the dense gases. This heat trap is the main reason Venus is hotter than Mercury despite being farther from the sun. On Mercury, heat escapes quickly because there's no atmosphere to hold it in. The planet heats up during the day, but as soon as the sun sets, the warmth disappears. This rapid heat escape is why Mercury isn't the hottest planet. On Venus, there's almost no difference between day and night temperatures. The thick atmosphere keeps the heat locked in, so the planet stays hot all the time. This is very different from Mercury, where temperatures change dramatically between day and night. Mercury's day and night temperatures are extremely different. The side facing the sun is scorching hot, while the side facing away is freezing cold. This is because there's no atmosphere to move heat around or keep it trapped. Venus's atmosphere acts like a giant blanket, trapping heat and keeping the surface hot. The combination of carbon dioxide and sulfuric acid clouds ensures that almost no heat escapes. This heat blanket is the secret to Venus's extreme temperatures. Mercury doesn't have a heat blanket. Its thin atmosphere can't trap heat, so the planet's surface is exposed to the cold of space at night. This lack of insulation is why Mercury can't hold onto the warmth from the sun. Venus wins the title of the hottest planet in the solar system. Its thick atmosphere, powerful greenhouse effect, and dense clouds combine to create extreme surface temperatures. Even though Mercury is closer to the Sun, Venus's unique features make it the real heat champion. Mercury is the runner-up when it comes to planetary heat. Its proximity to the Sun gives it intense sunlight, but the lack of atmosphere means it can't hold onto the heat. Mercury's unique environment makes it fascinating but not the hottest. To recap, Mercury is closest to the Sun but has no atmosphere, so heat escapes quickly. Venus is slightly farther but has a thick atmosphere that traps heat, making it much hotter. The key difference is the presence and thickness of the atmosphere. Even though Mercury is closer to the Sun, Venus wins the title of the hottest planet because of its powerful heat-trapping atmosphere. The science behind planetary temperatures shows that distance isn't the only factor. What a planet is wearing matters most. Venus's thick atmosphere and clouds make it the ultimate heat champion. Sometimes being closer doesn't mean being hotter, it's all about what you're wearing, even for planets. Venus's thick, heat-trapping atmosphere is like a heavy coat, keeping the planet warm no matter how far it is from the Sun. This fascinating fact reminds us that planetary science is full of surprises and challenges our assumptions about space.